Hello and welcome to SudoKanard. We're here to solve this puzzle called Twin Detector Sudoku by Polish author Krystian Świderski. I hope I did not too bad on the pronunciation. It was featured in the latest Sudoku Grand Prix, and I was a little frightened by the amount of arrows, so I decided not to solve this puzzle during the contest, but when I solved it afterwards, it turns out that it has a really smooth solving path. So this is what I'm about to show you. First, the special rule here is that whenever you have an arrow in a cell, it means that the number in this cell is the sum of the first few digits here. For example, if you have a 5 here, it could be with a 3 and a 2 there. It could be with a 1 and a 4 like this. It could even be, in such a case, the same digit here and there, and we will see in a moment that in this very case it has to be. And something very important is that all possible arrows have been given, which explains why there are so many. So I was saying those two cells have arrows facing each other, which means that this digit here is the sum of the first two digits there, so that this is worth at least that. And the same argument can be made in the other direction. This digit is at least this one, this digit is at least this one, and therefore they must be equal. So that's a very important fact to note, that those two digits must be equal, those two digits must be equal. And conversely, when you have such a diagonal arrow and you don't have the same arrow facing it, it means that this digit here is not equal to this one, and therefore this digit must be the sum of at least two other digits. And to find a place to start, you have to find a chain of arrows, something like this. And, well, at this point, I know where to look. This digit here is the sum of at least those two. And this digit is the sum of, is equal to this one. This digit is the sum of at least those two. Well, this digit is not equal to this one, so it must be the sum of at least those two. And we will see that this digit can't be very small, because this digit here is the sum of at least those two. And this digit must be the sum of at least those two. And those two must be different, because there are no arrows here. So here the minimum value would be with 1 and 2. Here the minimum value would be with 3, because it's the sum of at least those two. Here the minimum value is 1. Knowing this, the minimum value here is 4. And this digit is the same, so that the minimum value here is 8. And now this can't be more than 4, because if it were, this digit would be at least 10, and this is not allowed in standard Sudoku. So 4 is both the minimum and the maximum value, so it has to be the real value here. And the minimum assumptions here must happen. So that's a 3, that's a 1, that's a 2, and that's a 1, because let me recall that those two have to be different. Now this here can't be a 1, so this is more than 1, which means that if this sum here were to take this cell into account, we would go higher than 9, so that 8 can only be the sum of those two digits. We can't take this one into account, so that has to be a real 8. And the only possibility to fulfill this rightward arrow is to put a 6 in there. Now this must be the sum of at least those two. It has to be the 9. Those two arrows face each other. So that's a 9 as well. 9 here will be the sum of at least 2 digits. Here we're left with 5, 7, and 8. Well, this is the sum of at least 2 digits, so it can't be the 5, and this can't be the 8. You see that 7, 5, 1 wouldn't work. We would need a 1 here to fulfill the sum, so that has to be 8 and 7, and this is 5, and those arrows put a 5 in there. To fulfill this 8, we need another 2. This is the sum of those two. We can't include the 4 because we would amount to 11, so it has to be a 7. Now this arrow is fulfilled. For this arrow to be fulfilled, we need a 2 there. And this here will take at least those two, and it can't take this one. That's a 7. This is repeated here. This 4 must take those two cells. They can't be 2 plus 2. They have to be 1 plus 3, and because of this, that's the 1 here, the 3 there. This sums those digits. It can't be those 3 because then we would have an 8. So it's those two, and that is a 7, which is repeated here. We're left in this column with 4, 6, and 9. And this can only be fulfilled with 9 being 6 plus 3. And that's a 4. So as you can see, the amount of arrows made it difficult to find the breaking, but once you have the breaking, the deductions are just pouring in. All right, back to solving the puzzle. 8 without using those digits can only be 3 plus 5. This digit is repeated there, and it's not a 3. So that's a 5. That's a 3. This digit is also repeated there. Here we need 1, 4, and 9. 1 can't be the sum of those digits. 4 can be. And actually this digit is bigger than this one, so that can't be a 9. The same is happening here, so that's the one, that's the 9. The 9 is repeated here. 9 is the sum of those digits, so that's a 2. Here we're left with 6 and 8. Not sure at this point. Those must be 4 and 6, and they are repeated here. So at this point I don't know. Here we must have 2, 3, and 7. 4 is the sum of those. The only possibility is 3 and 1. This digit is the same as this one. 3 must be the sum here, so that's a 2, that's a 7. 7 works here. And actually this could have been found earlier. So there are many ways of, many orders of operations at this point. That's the 4, that's the 6, and that's 8 by the rules of Sudoku. This is also here. The 7 is the sum here, so that has to be the 6. And that's a 1. 8 is the sum here. And there are, oh, actually, this is the sum of those. That's a 3. We can't take the 8, and now 8 is working there. Here I need 2 and 8, so that's 2 here, 8 there. This sum now has to be a 9 with those 2. 3, we don't have the 6, we don't have the 1, so that's 2 plus 4. Here we need 5 and 8. Here we need 2, 6, and 5. That's 5, here 2, 6, and we can see that this 6 is working indeed. 4 and 5 work for this. Here I need 1 and 8. 1 can't be on the arrow. That will never be a 4. Here we need 3 and 6, so that's 6 and 3 there, and we complete the 8 with a 1. What is happening here? Oh, I've inverted the 8 and the 5. Yes, I had inverted the 8 and the 5. That's done, that's 4. Here the column needs a 9, and we can see that this is working. Here we need 7 and 3, there's a 3. All right. So this will include the 7, so that's a 2, that's a 9. This is now a 6. This has to be a 5. For this, 2 was not available. 7 and 8, so 8 and 7 here. Up there, we need a 7, an 8, and a 1. So once you know where the break-in is, this puzzle is just a smooth sail. And the main difficulty is to find where the break-in lies, which explains the 49 points. And I could have some regrets on not attempting this puzzle, but honestly, there was so much to do in this round that no regrets here. And I did all right on this round. Thanks for watching this video. See you soon on SudoKanard.